then I will follow basically the script. So we are fetching sequences again, like we did with Chimera, but now we are fetching the sequences into this JALView tool that is mainly a multiple sequence alignment tool, as you probably saw already. So fetch sequences, I have to select a database, which is the PDB, and then I take the structure of the pixars, which is U. I click on the first one. Okay. Hopefully. Oh, it's taking a bit. Okay, it was a bit too long. That's always, you never know. If the server of PDB would be down, we would have to do something else. Okay, so we have, because it has to change, that's why we have two lines, but they have, it's the same sequence in both of them. Okay, so we have one. Now we can close this one, and then we fetch the other one, select database PDB, and now it's the SARS-CoV-2 proteinase. So now I get it, click on the top one. Okay, wait a bit, we never know. Luckily, there it is. I know that I make the window a bit bigger, so we have several chains there because it's a PDB with many chains. And so we take the F1 here, and we Control-C, copy it into the other one. Okay. I did this move. I did something wrong, sorry. I copy everything, sorry. Have to sequences. Have to repeat the first part, sorry about that. Sorry, no, I put the wrong identifier in the second one, sure. Okay, sorry. 6X A4. That's the second one. There. Okay. Yeah. Okay. So again, we copy the F into the second. So now we have the two sequences, but they are one is from the pig SARS and one is from the human SARS. So they will be a bit different. And also they are not aligned. Okay, so they are just copied together. So if we select the two of them, like we discussed a moment ago, so then you go to menu, calculate pairwise alignment. So you get the alignment, and you can see that there are some identical residues. Here the representation is with bars, and the dots represent similar residues. So the identity is high, but not 100%. And you can read the identity, the percentage of identity here, which is one of the questions, is 44% identical. So there are many mutations if you compare one sequence with the other. And then if you say view in alignment editor here, then we can close the other windows. So now we have them aligned. And we have seen that some gaps have been inserted. So actually, maybe if I make the font a bit bigger. Okay, so you can see that the sequence on the top has one gap. And there is another gap here with two residues and a third gap here with one residue. Okay. And then if you color this, it can help you to be identical residues and similar residues. So in this case, we have identical residues colored in dark blue and like a lighter color for ones that are not identical and similar. In this case, because we have two sequences, we have all of them colored, but the blue one is indicating you the identities. And so now what we want to do is to contrast these two sequences regarding their structure. We want to know, for example, if that cysteine and that histidine that are important, first of all, if they are conserved. So we can look at the sequence of the one on the top, which is the PIXARS sequence. And so if you slide the pointer here on the bottom, you can see the residue we are looking at. So in this case, I'm pointing at histidine 41, and you can see that is also histidine in the human SARS. And if we go to 144, the numbers are the alignment, so it's a bit different, but we are around 140, so the cysteine should be here. There it is. So this is the cysteine 144, and it's also a cysteine in the alignment in the human protein. So the catalytic diet is conserved in the human protein. And now the question would be, are these residues also in the same positions in 3D in these two structures? So with YALView and of course with other programs, what you can do is if you select the two sequences and right click here and you select 3D structure data, okay, then it will retrieve the 3D structure from the PDB for those sequences. And then if you select these two sequences, there is a superposed structures here thing. And so if you say open new structure with JMOL, so this is another viewer, it's not Chimera, but it works similarly. Okay. And so we have it here. So what we have now is an overlap of the two structures. So you can see here that there are two of them. Okay. And so in principle, you could remove by going over here in view, so chain, you can remove things if you don't want to see the other chains, but we can also see without doing that in this case. And now the view that we have here, this 3D view, is connected to the alignment. So if I go over, you can see that as I move here in the alignment, the peak sequence, PIXARS, you have the side chains that are marked in the structure and also for the human one. So now what we can do then is we are going to check if the position of the histidine side chain and the cysteine side chain, if both of them are coherent, if the one in the human SARS is the same that we have in the peak. Okay, so I see it is there on the back, so I'm going to turn this around a bit. Let's see if I can do this and then zoom in a bit. Okay. And so there's, you can see the histidine there. And now I go down and I point to the human one, and you can see that the position is the same. So there is no change. This is the human one, big one, human one, big one. Okay, so the position is conserved. And now we can go to the cysteine in 141. Okay. I'm here in the big one. I have to move this because it's at the other side. Try like this. The window is a bit difficult. It would be easier if I would remove the other chains, but that will take a bit of time, and I don't want to do that. So anyway, so if I point to the cysteine, can I at this? Okay, yeah, this is better. So I'm turning this. I go to the peak, the cysteine in the big one. Okay, maybe I can make this a bit bigger. Bit bigger. So the big one is sorry. This maybe. Okay, you can see it approximately over there. And so if I go to the human one, it's at a very similar place. Okay, it's not 100% the same, but it's very similar. And actually, if I look at residues that are conserved around, like in this helix and these things, so they are also very in similar positions. Okay, so if I can do this, so this is, for example, another residue, human protein, big SARS protein. So one, the other. So I'm changing, and the position is very similar. So by doing this, this is a very efficient tool to check that the positions of all of those side chains are very conserved. And if there would be some difference, then you could use that to modify the drug that you would use for the human protein, basically. Okay. Good. Do you have at this point? I'm at the end of the exercise and of the lesson. So do you have any questions or comments for me or for Elmar? If not, okay, I thank you for your attention, and I hope that that you have learned a lot about protein structure. Elmar, I don't know if you want to say something.
Miguel, du hast schon alles gesagt. Ich wollte mich auch nochmal bei allen bedanken und hoffe, Sie haben was gelernt. Und falls es noch Fragen gibt, einfach eine E-Mail schreiben. Beantworten wir alles gerne.
Okay, so thanks.
Dann
einmal noch ganz kurz eine Info.
Yes,
Morgen.
Yes, yeah, of course.
Das geht jetzt für die Studenten, die Leute haben es vielleicht gesehen. Heute war die Ausnahme.